So when we're talking about indefinite and definite integrals, we've got area, and we have positive area if it's above the x-axis, and now we have negative area if it's below the x-axis.
Sorry. Is Maya's idea?
Restart my recording.
Maya's idea. Oh, it's a video too?
Yeah, it's a video.
7 questions.
Yeah, you can see that.
You have to do your intro, Miss Moy.
That's too late.
Welcome back to Miss Moy's Math Channel.
Yeah.
Here we're doing
Hi everyone.
Indefinite and definite integrals.
It's Maya.
Okay, what's the area of this little triangle?
1/2 base times guys. Don't forget to like and subscribe and hit that bell.
Tell me.
It's 4.
Guys,
4.
nobody's helping me.
I just helped you.
Thank you.
I also help.
What's the area of this? No.
That's circle pi.
Negative.
You're right, it's negative.
Negative
Negative pi r
4
squared.
pi. I can't tell.
Pi r squared. 1/2 pi r squared.
So what is it? Thank you. Over 2, because we want a half of it. Let's cut it here. What's that area?
Why don't we do trapezoid?
4.
Oh, you want a trapezoid? No, I want different parts. It's easier this way. This one is 12. This one is 4 again. This one is... Ugh. Sorry, fraction. This one is 9. And this one is 3. Cool. Okay, now we have our areas. Oh, this would be -3/2. This would be -9, and this would be -3. Okay. Now, if you want to find the integral from 0 to 7, that means add the area, positive and negative, up from 0 all the way to 7. So 4 plus 12 plus 4 is 20. Right? Yeah? Okay, and if I want the area from 0 to 13, we do 20 minus 13.5. Or 6.5. Okay, so that's the total net accumulated area. The area from -6 to 0 is -9 pi over 2. What's the integral from 3 to 3?
Trick question.
0. What's the area from, yeah, because it has no area. 7 to 0. Okay, see how this one is the bigger numbers on the bottom. So since you're going from 7 backwards to 0, you're going to say -20. Because essentially your delta x is going backwards, so it's negative. All right, 10 to 4. Oh,
Can we just not do that one?
no. 6.
It's -1.5.
Four. What'd you guys get? I got -0.52. Did you get -0.5? Huh? So we start here. We have -6. Oh, we're going backwards. So we have +6. So that would be 7.5. And then -4. And then -4. Okay. All right. -8 to 13. Ooh, the whole shebangies. 4 plus 4 plus 12 plus 4, 24. Oh, this is 6.5. We already know this is 6.5. 6.5 plus 4 is 10.5. 10.5 minus 9 pi over 2. Okay, what's the derivative at negative 6? Here's negative 6.
Oh, wait, negative 6.
No, that's negative 6. Right here. What's my derivative?
It's not differentiable, is it?
Yeah, it does not exist. Because this side has a negative 2 slope, but this side is a semicircle, and so the sides of a semicircle always have vertical tangent lines, right? You got a circle?
Oh, that's the term that you learned in geometry, right? Radius.
They've got vertical tangent lines on the side, right?
Your grade.
Okay. What's the second derivative at 6? Not, what does that mean? Like does not exist or 0? Which one?
It's 0. It's definitely 0 because you get a number as your slope for that segment. The derivative
Yeah,
of a
it's
number
0.
is.
That means there's 0 concavity. But it does not exist. It's not does not exist because the second derivative does exist. It's just 0. Okay, average rate of change in f, that would be f of 5 minus f of 0 over 5 minus 0. F of 5 is 4. F of 0 is 0. Over 5 minus 0, that's 4/5. Okay, true or false? If I find the area from 0 to 2, and I add that to the area from 2 to 4, will that equal the area from 0 to 4?
Should.
You're right, it's true. Okay, and then over which values of x is f of x not differentiable? Negative 6, 0,
2.
2, 5, 7, yeah, and 8. 11. Should we include endpoints? No. You can if you want. You don't have to. Okay. I'm not going to. All right. Easy peasy.
Of course.
Lemon squeezy. So here's 6 properties of definite integrals. The first property is, we've already discovered this, if you integrate with the same number for your bounds, then it's 0 because you have no area. But a's got to be defined in f of x. If it's undefined, then it doesn't equal 0. It just does not exist. If f is integratable on a to b, then the integral from b to a of f of x is equal to the negative integral from a to b of f of x. So that's if you want to switch the bounds. If you want to switch the bounds, you just make it negative. Okay? We just did this additive interval property. The integral from a to b of f of x is equal to the integral from a to c of f of x plus the integral from c to b of f of x. C does not have to be in between a and b. C can be like completely outside of a and b. But it will still equal as long as these two values are the same. If you have k a constant, you can bring the constant in front of your integral and integrate it and then multiply it by the constant. You can distribute the integral across addition and subtraction. So this k can come out here. You can distribute the integral across addition and subtraction, just like you can distribute a derivative across addition and subtraction. And then this one, if you're integrating just a number, it's k times b minus a. Because think about it, if k is just a number, then it's just a straight line. And here's a, here's b. And then to find the area of that rectangle, it's k times b minus a, because it's just a rectangle. Any questions? All right. Let's use these properties to answer these 6 questions. See if you can do it. And then we'll go over it. In what world? We've done 2 whole pages, Cole. Okay. Test your numbers or check your numbers. Did you get the same things? Do you guys have any questions on any of them? 3, 16, 5 times b minus a, 5 times b minus a minus 3, and 8 minus 2.5 is 5.5, and then 5 halves. No questions? Everybody's okay?
Of course.
Yes? Tell me now. I'm okay if you're not okay. But you have to tell me.
I'm Mish.
It calls a little spookily that you drop the interval.
The integral
Does that have
sign?
a name?
This integral sign?
Yeah. Is there a name for that, or is it just?
I don't know. I don't know. Okay. Find the following. The integral from 1 to 5 of 3 times f of x plus 4 equals 34. So let's use our properties. We can move the 3 outside of the integral, but only with the f of x, because the 3 is only multiplied by the f of x. And then we have the plus the integral from 1 to 5 of 4 dx equals 34. Okay, what can I solve? Can I solve any of it?
Yes.
What part?
The 1-4.
Yeah, the 1, 5, 4, right?
Yes.
This is equal to 4 times 5 minus 1. So we still have 3 integral 1 to 5 of f of x dx plus that equals 34. Okay, and then 4 times 4 is 16, right? 16, then we move it over to the other side. So we have 3 integral from 1 to 5 of f of x dx is equal to 18 left. And so integral from 1 to 5 of f of x dx is 6. Yeah. Okay. Now let's think about these two problems. If we have an even function, and I know the integral from 0 to 3 is 8, what's the value from negative 3 to 3? Well, give me an example of an even function.
Square.
Okay. Okay, if I know the area of an even function from 0 to 3, if I know this area equals 8, right, from 0 to 3, then what can I say about the area or the value of the integral from negative 3 to 3? It would be double it, right? So 16. Are you with me? Okay. Odd function. Give me an odd function.
X cubed.
Oh, no.
Minus x.
Sine x.
Aw.
Look how fun that one is, right? Okay. If you know the area from 0 to 3 is 8, what do you know about the area from negative 3 to 3?
It's negative.
That's negative 8, and then negative 8 plus 8 is 0. Okay? So even and odd functions should tell you a little bit about their symmetry. All right, now these problems down here, you should know the shape of all of these graphs, then you can draw the shape and then you can evaluate. This is an equation of a semicircle. So semicircles always have an equation of y equals plus or minus square root of r squared minus x squared, because it's like x squared plus y squared equals r squared, but if you solve for y, then you get this. Okay? All right, so this is an equation of a semicircle, radius of how much? Radius of 2. Semicircle on the positive side because it's a positive root. So how do I find the area from negative 2 to 2? 1/2 pi times 2 squared, right? Or 2 pi, right? Yeah?
Yeah.
Yeah. Okay. Integral from negative 3 to 0 of 1 plus from 9 minus x squared. So let's split that to integral from negative 3 to 0 of 1 dx plus the integral from negative 3 to 0 of square root 9 minus x squared dx. This one is 1 times 0 minus negative 3, so 0 plus 3. And then this one is an equation of a semicircle, positive, out 3, but we're only going from negative 3 to 0, so we only want this section. So that would be 9 pi over 4, yeah. So our answer would be 3 plus 9 pi over 4. Okay? Let's do another one together. Okay, this one It is an absolute value graph. I'm going to split it into two. Integral from -2 to 4, the absolute value of x dx,
Oh my.
plus the integral from -2 to 4 of 3 dx. This would be 3 times 4 plus 2, right? And then this one, we'll have to draw the graph of an absolute value to figure it out. So it looks like a V. And from -2, this is 2, so the area will be 2, right? And then 4 is 4, so 4 times 2 is 8. Did I do that right? Everybody with me? So 8 plus 2 is 10. Plus 8 times, or 6 times 3 is 18. 18 plus 10 is 28. Okay. All right. You try the last 3 problems and let me know if you get the same answers that I do. Split your integral, use the properties if you can, but this next one you don't have to. Just think about it. Oh, was it you, Aiden? Yeah. How'd you do, guys? Do you need another minute or? Yeah? Okay. Huh?
Way too much arithmetic for my taste.
Yeah. Drawing shapes too. Drawing triangles and finding the area.
Can I have my sister get my homework tonight?
Sure. I mean, it's kind of going back to like when you used to
This is totally when we used to count the squares in third grade.
count the squares. Yeah, exactly. Okay, I got 0 for this one, 28.5 for this one, and 0.5 plus pi for this one. Did anybody get anything different from what I got? Yes? Which one? The last two? Did you split your integral up? Okay, so this one should have been fine, right? And then the 3 I pulled out. And then I just graphed y equals x. But since I'm only finding the area from 1 to 5, I cut it off here at 1, like 1, 1, so I could make a rectangle. And then the height here would be 3, and the base here is 3. So it's 3 times 3 is 9 over 2. So that's how I got that part. And then that, don't forget to multiply that times the 3. And then add it to this part. But it's probably something small. This one, it's do 1 times 2 minus 0. The area of this, you're only going from 0 to 2, so it's not 2 pi, it's just pi. And then I split the integral with a 3. And then I graphed negative x. And found the area from 2 to 5 of negative x. That's kind of annoying to do, right? But if you're given a graph with just shapes, you have to do it that way. There's no other choice. Okay, now, let's say we don't have shapes, we just have equations or polynomials. Then what we have are, what we do is things called antiderivatives. So an antiderivative is where when you do it, your answer, if you take the derivative of it, will be what your equation was. Does that, I don't know what I'm saying. So now we're going to work with indefinite integrals. Indefinite integrals do not have bounds on it. So for that reason, we have to do something special when we do an indefinite integral. So when we antiderive, yeah, something we have to add a constant. Because if this was my derivative, and if you want to antiderive, there's no way you can remove an apostrophe if no apostrophe is there. So to antiderive, we make this little f a big F to show that we took the antiderivative of it. So, what is the antiderivative of 2x? What's the derivative of what is 2x? X squared, good. But couldn't f of x be x squared plus 2? And couldn't f of x be x squared plus 7? You know, and so on and so forth, right? All of these have a derivative where the derivative is 2x. Yes? All right. So, because when we do that, we don't know what this, like, we could have had a constant there when we had our original function, but we don't know. It went away when we took the derivative. That's why we have to add a plus c to say that there could have been a constant there, when we integrate it, but we don't know for sure if that constant is there or not. So you always have to add a plus c anytime you do an indefinite integral. Okay, so this is what your indefinite integral will look like. It just has no bounds. It's just f of x, and then this dx is your delta x still. And then the plus c is your constant of integration. Okay? All right, cool. So, basic integration rules. We've gone through all of these. The only one that you really need to know for this unit is how to undo power rule. So to power rule, you take the exponent, bring it down, and subtract the exponent by 1. To integrate it, you're going to want to add 1 to the exponent and then divide by your new exponent. And then add a plus c. But your new exponent can't be 0. That's the only special thing. Okay? All right, so let's find the antiderivative of 8. What's the antiderivative of 8?
I don't know, bro.
And then add a c. Okay. So f of t equals, and then we add 1 to the exponent, so we make this 2t to the 6th, and then you divide by your new exponent, so divided by 6 plus c. And then you might want to simplify to be 1/3 t to the 6th plus c. Okay. This one, rewrite it as a negative exponent, so 2t to the negative 3. So capital G of x will equal, add 1 to the exponent, so I get 2t to the negative 2 divided by negative 2. Divide by your new exponent and then tack on a plus c. So this will be negative 1 over t squared plus c. This v of t, when we integrate, will become capital V of t. Now remember, this is square root 2 times t to the 1/2. So you can't take the 2 out of the root, even though you're integrating. This 2 is also rooted. So leave the root by itself. Okay, we're going to add 1 to the exponent. That would make it t to the 3/2. But then we're going to divide by 3/2 or multiply by 2/3. So we'll make this 2 root 2 over 3 t to the 3/2 to include the root 2 still. But then you have the 2/3. Don't forget your plus c, right? And then the next one would be capital H of x is, oh, you don't know the reverse chain rule yet, so we're going to FOIL this out. 9x squared minus 6x plus 1. So let's integrate that. That would be, what would it be, guys? 9x cubed over 3. 3x cubed. 6x squared over 2, so minus 3x squared. Yeah? And then what else? Plus x plus c. Cool. And this one right here, we can distribute this term in the bottom to each one in the top. So let's simplify and make this x to the negative 3 This 4x over x to the 5th is plus 4x to the negative 4. And this is plus 5x to the negative 5. So capital R of t is what is it, guys?
Negative 2x to negative 1/2.
Yeah, negative 1/2 x to the negative 2 plus 4x to the negative 3 over negative 3. Plus 5x to the negative 4 over negative 4. I forgot. I don't have enough room. Just so add on a little plus c at the end. Okay? All right, last 2 questions and then we're done for today. So, how do you figure out what plus c is, right? So in order to figure out what plus c is, they're going to give you some sort of point that you can use to find c. So once you've taken the antiderivative, which we'll do now, f of x equals, okay, let's integrate, let's antiderive this. That would be 1/3 x cubed, right? Plus 1/2 x squared minus 7x plus c. Okay? Once you've taken the antiderivative and you have that plus c, what you can do is you can plug in your x and your y and solve for c. So 1 equals 1/3 times 3 cubed plus 1/2 times 3 squared minus 21 plus c. And then solve for c. C, you get 8.5 for this one. So your original equation, now you have your constant. 1/3 x cubed plus 1/2 x squared minus 7x plus 8.5. And then you have your whole function, including your constant. All right, you try B, and once you try B and you check your answer, then we're done for today. That one had an easier number than the other one. Did you finish? Yeah? Okay. Check your answer. Do you guys have any